All right, so good evening, everybody. Thank you very much for joining us tonight. My name is Jennifer Ahern. I'm the Chief Officer in the Ministry of Health and Culture, and Mosquito Research and Control Unit is one of the agencies under our ministry. So very excited to be here. I have apologies tonight from the Honourable Premier, Alda McLaughlin, who is also our Minister for Health and Culture, and also for Councillor Roy McTaggart, who is our ministerial councillor. They had both hoped to be here tonight, but they have another engagement that took them away. So they did send their apologies. And I also want to welcome and acknowledge Honourable Minister Tara Rivers, who's the Minister of Education, Employment and Gender Affairs, and also one of the elected representatives for the district, and Captain Eugene Ebanks, another one of the elected representatives. Thank you both for taking time out to join us tonight. And thanks to all of you for taking the time to come tonight. We have some really exciting information to share with you. This is an opportunity for you all to come and hear firsthand what is being proposed and some of the science behind it, some of the experience that is being brought by the OXITEC team. I'm joined tonight, of course, by the Director of MRCU, Dr. Bill Petrie, who I think most of you will know and recognize. We also have Dr. Renaud Lacroix, who is the Project Manager for OXITEC Cayman Limited. So he's the local representative here. And then also on the panel is Derek Nimmo, who is the Product Development Manager for OXITEC. He's based in the UK, so he's come over tonight to join us and to give the presentation. So the format for this evening, Dr. Petrie is going to say a few words, and then we're going to have a presentation by Derek. I would ask if you could hold your questions until the end of Derek's presentation, because you may find that a lot of the questions you have are answered as he works his way through the presentation. There are some little sticky pads at the back, as long as some other cool swag. So if you want to grab a sticky pad and a pen and note your questions down as they come to you through the presentation, then we'll make sure that we address them at the end. So with no further ado, I would ask first if you could all just check and make sure your cell phones are on silent or vibrate before we begin, if you don't mind. And then I will now turn it over to Dr. William Petrie, who will just say a few words, give a bit of an overview and some background. So Dr. Petrie.
Thank you, Jennifer. First of all, how's the sound? Everybody hear me okay? Because I'm going to have to compete with a pair of ching-chings up here. Good evening, ladies and gentlemen, boys and girls. Thank you very much for all coming. We want to talk to you tonight about this, what we think is a very exciting project. My name is Dr. Bill Petrie, Director of Mosquito Research and Control Unit, as Jennifer said. We are going to embark upon a collaborative project with OXITEC, a biotechnology company out of the UK, out of Oxford in the UK. I'm going to say a few words, not take too long, and then pass over to Derek Nimmo for a presentation, and then we'll have questions and answer session at the end. But I do first want to say a few words. I have some thank yous to give, so please bear with me. I need to thank our ministry, the Ministry of Health, in particular, Chief Officer Jennifer Ahern and Deputy Chief Officer Nancy Barnard for their continued support in the ministry. Also, the Honourable Premier for government support and his statement in the House, in the Legislative Assembly that he gave a couple of weeks ago. Also, and I need to mention Mr. Roy McTaggart, who's the Councillor to the Ministry of Health. Mr. McTaggart has had a keen interest in this project since he has come on board, and I know he's followed it, and he's also been following very closely the developments with Zika, the outbreak and the epidemic. I also want to take the opportunity to thank all 4 of the West Bay elected members, 2 who are not here, can't be here this evening, but I want to thank all 4 because we had an opportunity, MRCU and OXITEC, to talk with the 4 elected officials during, they made time for us during a busy session of the Legislative Assembly, where we were able to explain the project to them, and they had a few questions for us. And that was a very good opportunity, so I wish to thank them for that. So Tonight, we want to talk about only one mosquito. Now, this is an important point. It's only one mosquito type that we're going to talk about. The scientific name is Aedes aegypti. It doesn't really have a common name, although historically it's known as the yellow fever mosquito. More recently, perhaps the dengue mosquito, but now we've also had in the past couple of years chikungunya, and now I'm sure you're all aware of Zika. And all of these diseases are carried and transmitted by the same mosquito, Aedes aegypti. Aedes aegypti is, look, this is a public health menace. Let's not make any bones about it. It is also a very difficult mosquito to control. It's a real challenge for people in my department and my business to get rid of or even suppress Aedes aegypti. So we have, over the years, looked at several different methods, researched other projects to assist in getting rid of Aedes aegypti or reducing the population. And we have collaborated with OXITEC in the past on their technique and found very promising results with some field trials that we conducted some years ago. So we are very excited to embark now with OXITEC on what we characterize more as an operational rollout. This is a larger scale operational rollout of this technique, which we have a lot of confidence is going to give us good results. I want to emphasize, just to finish up, that this is very much a collaborative effort between MRCU and OXITEC. And indeed, OXITEC have formed a local company now called OXITEC Cayman Limited, have 2 staff here on the ground, Tally Cohen at the back there, and Dr. Renaud Lacroix is the project manager. But OXITEC Cayman have also recently employed 4 young local people to work on the project. And we have 3 of them here tonight. One of them, Ken, couldn't be with us tonight, but we have 3 at the back there. Giselle, Heidi, and Isabella, if you want to just identify yourselves. At the risk of embarrassing the employees, I have to say that I've been very, very impressed with their work ethic, with the way they conduct themselves, their enthusiasm, and their willingness to work, their interest in the project. And I think this is a very positive thing for Cayman and for this project. So just very quickly, the essence of this project, the essence of this technique, I should say, is the use of effectively sterile male mosquitoes, which are released to the environment, then mate with the wild female Aedes aegypti mosquitoes, which are already out there. The progeny, the offspring of those female Aedes aegypti mosquitoes, then do not complete development. They all die, so that they never reach maturity, they never become flying, biting insects capable of carrying disease. And if you do this over time, we have shown that you can significantly reduce the population of Aedes aegypti in the wild, and that is the aim, the overall aim of this operational rollout. So with that, I'll pass over to Derek Nimmo for his presentation. Thank you.
Thank you very much, Bill. Everyone hear me? Good. So I'm going to talk to you today about the Friendly Aedes aegypti project. I'm going to give you a little bit of information about the mosquito, and I'm going to give you a little bit of information about how the technology works, where we've used it before, and also where it's been endorsed before. So this is not a new technology. This technology has been used for over 6 years now in other places, including the Cayman Islands. So I want to talk to you about that, and then a little bit about what's going to actually happen in West Bay over the next several months. So hopefully it gives you a rounded view of the technology, what's happening, and where it's been used before. Oh, I've gone too far. So mosquitoes are the most dangerous animal in the world. They cause more deaths than all humans killing other humans, all snake bites, shark attacks, other diseases. They cause an incredible amount of human suffering. And we obviously have been trying to control this mosquito for hundreds of years. The Romans used to drain swamps so that they could control the malaria mosquito. And people have been trying to control mosquitoes with new technologies and new systems for many years and many decades. Now, in the case of Aedes aegypti, it transmits, as Bill was saying, several nasty diseases. It transmits yellow fever, dengue, chikungunya, and Zika virus. Dengue, which I think most of you know about, is a nasty tropical disease. It's a virus. It infects people through the bite of the mosquito, and it causes what's called bone break fever, where your muscles contract so much that it feels like your bones are breaking. It's a very nasty disease. It infects about 100 to 400 million people every year, and there's no specific treatment or vaccine for this disease. There are some vaccines being developed, but there's also vaccines for yellow fever that have been around for decades now. But we still have outbreaks of yellow fever. In Angola recently, there was 150 deaths from yellow fever. So using a vaccine is good. It's complementary to any sort of mosquito control, but getting rid of the mosquito is the best way to control the transmission of these diseases. So Aedes aegypti is a growing global and economic threat. Aedes aegypti has spread around the world in the past few hundred years. It is not native to anywhere outside of Northeast Africa. So getting rid of this mosquito actually restores the environment. So as I've said, it's the primary vector of all those diseases. What else have I missed out? Yes, so Aedes aegypti, why does it transmit diseases so effectively? It's because it's anthropophilic, and all that means is that it prefers to feed on humans. So the females that are the ones that bite, males don't bite or transmit disease, but the females bite almost exclusively humans, and they live in and around your house. You'll find any Aedes aegypti inside your home and around your garden. And it lives almost exclusively around that area. It's an urban mosquito. Lives with you, basically. And that's what makes it so efficient at transmitting disease. Aedes aegypti doesn't occur in large numbers. In fact, you'll hardly ever notice being bitten by Aedes aegypti. It's more the other mosquito species that are more the vicious biters. Aedes aegypti is a bit more sneaky. And it doesn't have to occur in large numbers because it feeds on humans. So it will bite a human that's infected. That mosquito will become infected about 3 to 5 days later. And then she will bite maybe a dozen or so more people, and she'll spread that disease to a dozen or more people once she's infected. And that's how it becomes so efficient at transmitting these diseases. One of the reasons it's very hard to control, as Bill was saying, is that this mosquito lives in and around your home. So it's very hard to treat with insecticides because they're inside your house. So when they come over spraying with the aircraft or spraying along the road, the mosquito's in your house. It's hidden from the insecticide. It also breeds in very small pools of water. I've seen Aedes aegypti breeding in, the Coke bottle caps, the little red Coke bottle, it can breed in those. So trying to find all those different breeding sites of Aedes aegypti is almost impossible. You can do yard cleanups, you can hopefully get rid of a lot of them, but you will not get rid of all of them. It's very hard to control by conventional means. And also, it's become resistant to many of the current insecticides. In the Florida Keys, it's resistant to 4 out of the 6 insecticides that they currently use, and I believe it's resistant to most of them in the Cayman Islands as well. So, desperately needing new tools to control this dangerous mosquito. So the WHO is obviously very worried about Zika. So recently, they held a meeting to look at all the different new technologies that are out there. And they looked at ours, and they said, well, okay, What's the impact of the national and international emergency? So with OXITEC's technology, we're focusing on the control of Aedes aegypti. Good, that's the mosquito that transmits the disease. Tick. There's urgency for proven actions, for research. So we have a proven technology. We have used this over the past 5 to 6 years, and we've shown very good control. I'll come on to the trials and the programs that we've done in a minute. And the mosquito control agencies can adopt these innovative tools on an operational basis. So this isn't small scale, this is something they can use to actually affect a control program now. Actually control this mosquito effectively. Zika is a threat now, right away. It's spreading. It spread out of Brazil within a year. It spread over the whole of the Caribbean, up through Panama, into Mexico, and we're getting imported cases into the US. From assessing all of that, the WHO has recommended the use of OXITEC Aedes aegypti. This is a new tool. It's a powerful tool. They recommend that people use it. So, current tools that are being used to control Aedes aegypti. I've given you a little bit of background, but basically, one of the proposed tools is to remove the breeding sites of Aedes aegypti. There's so many of them that you can't do that. It's impossible to remove all the breeding sites. Insecticides. It's becoming resistant to most insecticides. They're no longer effective, and it breeds inside your house where most insecticides don't get to anyway. I'll give you an example. The Florida Keys Mosquito Control District spends $1.1 million every single year just on the control of Aedes aegypti, this one insect, because they had a dengue outbreak back in 2009, 2010, and that caused them to think, well, okay, we really need to control this mosquito. They threw everything they had at it. Breeding site control, door hangers on everybody's doors saying, please clean up your yards. They had 20 inspectors, 3 helicopters, 5 airplanes. They were spraying the latest insecticides, something known as BTI, it's like a toxin. They were using everything in their arsenal against this mosquito, and they could only achieve 30 to 50% reduction of this mosquito, which was not enough to guarantee no disease transmission. And they're one of the best mosquito control units in the world. Sorry, Bill. But they are one of the best in the world. Yeah, sorry, excluding the MRCU. Bill told me to say that. Well, the MRCU was technically the first to test out our technology, so yeah. So the Florida Keys Mosquito Control District, they cannot control this mosquito, and nobody else can either. Okay, there's a lot of people out there who propose technologies like removing breeding sites and insecticides, etc. These are not new. They do not work effectively against Aedes aegypti. Bed nets are also ineffective. If you didn't know, Aedes aegypti bites throughout the day. It does bite more in the evening and the morning, but it tends to bite all through the day. So bed nets and things like that are not effective in controlling getting diseases from this particular mosquito. So these controlling this mosquito is a challenge. And this mosquito is not going to go away on its own. It's here to stay. So all these different control methods, we need a sustainable solution. We need a new tool to be able to control this mosquito. So that's what I'm going to talk about you now. I'm going to talk about the friendly Aedes aegypti. This is a genetically modified mosquito. I want to get that out the way with first, just so everyone's really clear about that. This is genetically modified. We have inserted a gene into this mosquito. I'll be able to tell you everything about it in a minute, but just make sure you know that. So We developed this mosquito back in 2002. It was originally produced, and we've been working in the lab testing this mosquito and making sure it does what it says on the tin, which is that it's a self-limiting technology, that it works against mosquitoes from around the world, that it works in the field, and that it's safe and effective. We have introduced just 2 genes into this mosquito. I'll go on to the details about those genes in a minute on the next slides. But one of them is a self-limiting gene. This is the gene that is the effective gene that works to actually cause the mosquito to die, basically. And this is how we use it in a control program. There is also a fluorescent marker. This makes the mosquitoes glow. Now, you can't see the mosquitoes glowing. Unfortunately, you don't get all these glow mosquitoes flying around. It's something you can only see down a specialist microscope, that we bring the mosquitoes back to the lab and you can see them down the microscope. This technology reaches where other tools cannot. We release males into the environment. Remember, the males don't bite or transmit disease. Those males have one job: to go and find females and pass on their genes. So when we release those males, they're going to go and find the females that are in your house, under your house, in your garage, wherever. That's what they're programmed to do. There's no need for anyone to go and search for them. There's no need for anyone to do it. You could just open a pod of these mosquitoes, off they go, and they do their job. It reduces, not replaces, the mosquito population. So just to make it clear, this is not any sort of technology where it stays in the environment, that it's a predator that eats that mosquito and it might eat other mosquitoes. It's nothing like that at all. That's why we call it self-limiting. When we stop releases, it disappears from the environment totally. So this slide gives you a little bit of information about how the technology works. Originally, we put these 2 genes into the mosquito by a technique called micro-injection. And this is quite a neat technique. I think that because I'm a scientist. But basically, you have a very fine needle. You have your DNA in that needle, and you inject it into the eggs of the mosquito. The DNA then inserts itself into the genome of the mosquito. And we can search for that by the fluorescent marker in the mosquitoes. Now, we don't have to inject every mosquito every single time. Once we've got the DNA in the genome, we make it what's known as true breeding. So you know when you make a plant true breeding for like yellow flowers or purple flowers, it's exactly the same. We select for that gene and make it true breeding. So now we've got a strain of Aedes aegypti that will always contain our self-limiting gene. Now we can, obviously that self-limiting gene causes the mosquito to die, but we can switch that off with a dietary supplement called tetracycline. And that's just a common antibiotic that everyone uses. You use it for a cold or an infection. We put that into the rearing water, and it allows the mosquitoes to survive. And that allows us to rear them in large numbers so that we can produce the males for a release program. I've said this already, but after the releases stop, the genes do not persist in the environment. The reason for that is the males that we release, they die within about 2 to 3 days. Wild-type males don't live much longer. They only live about 5 to 7 days. But the released males, they live about 2 to 3 days. Then, if they mate a female, they pass on the self-limiting gene to the offspring, and they die. And where we've done trials before, we can actually use the fluorescent marker in the mosquito to track and trace, to basically follow that in the population. We can bring back eggs from the field. We have little traps, little ovipots. The wild-type females lay their eggs on those ovipots. We can bring those eggs back to the field, hatch them, and we can look for that fluorescent marker. And within 6 to 8 weeks, after we stopped all the trials that we've done before, we can find no evidence of that fluorescent marker in the environment. So we know it's self-limiting. We know it does not persist in the environment. And this is just a very, it's a very bad sort of image of the slide, I'm afraid. Sorry about that. The projector's not quite working as well as we hoped. But basically, we've done trials in the Cayman Islands. That was back in 2009, 2010. I did those trials along with Renault over there. So we've had a long history here in the Cayman Islands. In 2009, we did basically a trial where we were looking to see that the males we released actually mated with the females and that it would work. So we did a trial of actually sort of just seeing if it would work. And then in 2010, we did a suppression trial in East End in the Cayman Islands. And in that trial, we showed well over 90% suppression of the mosquito population in East End. How did we show that? Well, we had an area where we were actually releasing our mosquitoes, and we had another area that was a control. And they were virtually next to each other. There was about 200 meters or 300 meters separation. And we could actually compare one to the other. And when you compare them, we had a 96% reduction in the mosquito population. That trial has been published. That's available for everyone to view. It's been peer-reviewed in a published paper. So all the data is available for anyone to see. We've also done several trials in Brazil, 3 trials now, and in every single trial we got over 90% reduction in the mosquito population. We've actually gone through the regulatory process in Brazil, and we've now got permission to release anywhere in Brazil. And we've also got permission to commercialize our mosquito in Brazil, and we're building a factory to be able to treat 200 to 300,000 people in Brazil, hoping to have that up and running in the next 8 to 9 months. And we've also had another factory we built about 2 years ago now, and we've been treating a town called Piracicaba, about 5,000 people, and we're expanding that now to 35 to 60,000 people. So we've had great success in Brazil, and we're expanding the program there very quickly. We've also done a trial in Panama, where we got, again, over 90% control of the mosquito species. Now, in Panama, interestingly, we looked at, okay, if we remove Aedes aegypti, does it affect, the spread of other mosquitoes? And we looked specifically at Aedes albopictus, which is a very closely related mosquito to Aedes aegypti. Albopictus can also spread dengue, chikungunya. I think it's been implicated in Zika as well. So it can also spread those diseases, but it's less efficient at spreading those diseases because it doesn't exclusively feed on humans. It'll feed on dogs, it'll feed on birds, it'll feed on cats. So it's not quite as efficient a transmitter. But people fear that if we get rid of Aedes aegypti, which is an invasive mosquito, and the Aedes aegypti is there, it will come in and take over where aegypti had been removed. We found no evidence of that over the 12 months that we did the trial in Panama. We reduced the Aedes population by over 90%. We saw no evidence that albopictus suddenly rushed in and overtook aegypti there. That is over 12 months, okay, so it's just a time sort of period, but it's a time period where you'd expect albopictus to be able to come in and take over. Good, so yeah, basically that slide says this is not new. We have trialed this in other countries and in the Cayman Islands, and we've shown well over 90% suppression. No other technology to date has been able to show that sort of suppression, especially over the past sort of 10, 15 years since, DDT was very good. It was exceptionally good at controlling insects, but unfortunately it obviously had a lot of other effects on not just the environment, but moving up the food chain. So if you don't already know, and I've already said this, but I just want to highlight it, Aedes aegypti males do not blood feed. They don't have the mouth parts to be able to blood feed. They just feed on sugar. They just need sugar as energy so that they can go and find the females and be able to pass on their genes. It's the females that blood feed. They need the blood meal as energy to produce eggs. Now, a single female can produce 100 eggs per blood feed, and she can have up to 5 to 6 of those what we call gonotrophic cycles, which is where she takes a blood meal, uses it as energy, produces the eggs, lays them, That's one gonotrophic cycle. Then she takes another blood meal and then produces her eggs and then lays them. That's another gonotrophic cycle. And that's how she transmits diseases, because she takes a blood meal, gets infected, and then she bites somebody else because she needs to produce more eggs, and that's how she passes on these diseases. Good. This is an environmentally friendly approach. And we say that because it's very targeted. Those males that we release will only mate Aedes aegypti females. They do not mate anything else in the environment. They do not affect anything else in the environment. And they cannot establish in the environment because of this self-limiting gene that we've put into the mosquito. We've also done predator studies. So we have looked at fish, we've looked at birds, and we've looked at other predatory insects. And we said, well, you know, if we feed this to them, does it affect them in any way? And it doesn't. Even at 100% of their diet, with this particular mosquito, it does not affect their development, does not affect how many eggs they produce, does not affect anything in their development cycle. So we've done those tests on predators and shown no effect. So this slide, I'm sorry you can't read the yellow circle. Well, actually, no, it's green on here. 2002, we created the strain. In 2009, we did our first ever Cayman trial, 2009, 2010. And then in 2010, we started trials in Brazil, going through the regulatory process in all of these countries. I want to actually stress that. We've never released any mosquitoes without regulatory approval. That's true for the Cayman Islands, true for Brazil, true for Panama, true for the US, true for Malaysia, true for India. You know, we're working in all of these countries at the moment. 2014, we did the Panama trial, showing the no albopictus niche replacement. That just means taking over where Aedes aegypti was removed, and no persistence in the environment. And then 2014 to 2016, Brazil, CTM Bio, who is their regulatory agency, approved the release of our mosquitoes anywhere in the world. Anywhere in Brazil. We've been working in the US for a long time. Since about 2009, 2010, when they first had that dengue outbreak in the US, I've personally been working on a project with the Florida Keys Mosquito Control District to use this technology in the Keys, in the Florida Keys. And we've been going through the regulatory process with the FDA, and we've been giving them information, we've been giving them basically SOPs, which are standard operating procedures on how we're going to do a trial, how we're going to rear the mosquitoes, how we're going to release them. We've also built a facility in the Keys that's been inspected by the CDC and the FDA, and it's been approved. And about 2 months ago, the FDA and the CDC and the EPA all assessed an environmental assessment that we've submitted to them. And this environmental assessment was 283 pages long. It's publicly available. You can download it off the website, FDA website, regulatory.gov. We can give you details if you need them. And you can read that 283-page document. That has all the information that they used to come to what's called a finding, or preliminary finding of no significant impact. And what that means is they looked at everything from the gene itself, how it functions, whether the gene is toxic or allergenic to humans. It's not. Whether there's going to be any effects on the environment or human health. And they don't think there is. And that's why they issued this preliminary finding of no significant impact. That was available for public comment. And that was for 60 days, and that finished about 2 weeks ago. And what happens then is the public is able to read that and able to put comments onto the website and say, well, have you thought about this? And so they look at those comments and they look at them and they say, well, is there anything there we haven't thought about, we've missed, or something like that? If they don't find anything that increases the risk, they issue what's called a final FONSI, a final finding of no significant impact. And that allows us then to go ahead with the trial in the Keys. But again, that document is available for anybody to read. And I would encourage you, if you're inclined that way, to read a 283-page document, to go and read it, because it's got all the information in there. And this is not just OXITEC with this information. I'd like to highlight this information has been done with independent collaborators all around the world. The MRCU was an independent collaborator. They had a lady called Angie Harrison working on it with us. She independently helped us with the trial, did the releases, got the data. She wrote up the paper. Okay, so this is not just us saying this or looking at the technology. Have I missed it? Yes, WHO, you saw on that original slide, has recommended our technology for operational use. Good. Okay, the West Bay project. So I apologize for the quality of the picture, but if you've picked up the leaflet, there is a little addition inside that shows a better map of the release area. The release area is highlighted in blue there, and the control area, which is the area that we're going to compare to, where we don't do any releases, is in yellow. So yeah, announced May the 5th. We're doing a couple of months of community engagement like this event here, but Renaud and his team have done a lot of other community engagement and doing more over the next month. West Bay was chosen due to high mosquito numbers, high Aedes aegypti here. But that's true of actually quite a few places in the Cayman Islands. But you've also had dengue and chikungunya here. And because of the position of West Bay, it is an ideal place to start a rollout program across the whole island. So if we can control it in the corner of West Bay, we can roll out down through to Georgetown, across Georgetown, and then out and through the rest of the island. So it's also a good place to make a start on the technology because of the way the technology works. Current measures that are being used to control Aedes aegypti will not change. This technology is complementary to almost any other technology that's used out there to control Aedes aegypti. Breeding site reduction, larvicides. The only one it's not really compatible with is adulticides that kill the adults. But even then, we can work around that by not releasing when they're going down the road fogging. So we can just time the releases. The treated area is about 1,800 people, about 300 acres initially, and then obviously we're going to roll out from that as we get control. The releases, they'll typically be 3 times a week, Monday, Wednesday, Friday, or something like that. And the total numbers released will depend on the number of wild-type mosquitoes out there. When we do a control program, we release our males that we call an overflooding ratio. So we have to release more of our males than the wild-type males that are out there because our males are at a slight disadvantage because we're releasing them from a truck into the middle of a road. They're not where the females are, so they have to go and find the females. So we have to release more of them to be able to achieve control. But that all depends on how many wild-type females there are out there. So we will be adjusting our releases as we go along, dependent on the wild-type females out there. But basically, we'll be releasing somewhere between 100 and 200,000 of our males per release. Now, that sounds a lot, but in the Cayman trial that we did before in East End, we were releasing roughly the same numbers that we have here. And we'd open a pot, and there'd be about 1,000 males in there, and within about 30 seconds, you couldn't see them. They'd disappear. They go and hide underneath the bricks, underneath the houses, and you don't notice them. We'll have weekly monitoring. 60 overtraps are placed around the area, 15 adult traps. These are called BG traps. They're basically a fan that sucks the mosquitoes in. There's an attractant, smelly attractant. It smells like feet, and that attracts the mosquitoes, and then they fly in and they get trapped in there. Now, from the OV traps, we can bring those back to the lab. We can look for this fluorescent marker that we've got in there, and we have a very clever way to use it. When we bring the traps back, we count the number of eggs, we hatch them, and we say, well, how many of those were fluorescent and how many of those were non-fluorescent? i.e., how many of those eggs came from a female that had mated one of our males? If that ratio is over 50%, we know we're doing well. We're releasing enough of our males. If it's not over 50%, we know we're not releasing enough and we need to release more of our males. And we can almost do this in real time, week by week, assessing how many we release and whether it's working or not. And we can use that as a very powerful tool to be able to show that, we're getting control. In every single trial so far, when we've reached 50% fluorescence, within 3 to 6 months, we've achieved this over 90% control of the mosquito population. And also, we'll have the control area without mosquitoes, without our mosquitoes being released. And there we'll use that to compare the control effect. So this slide is to show, give you a little bit of an overview of how most control programs work. We obviously start with production. We've got to produce the mosquitoes. We've got to produce them at the level of about 100 to 200,000 per week. And we have a shipping container, which I'll show you in a minute. I've got some photographs of that, sited at the MRCU headquarters. And that's where we rear the mosquitoes and sort the males from the females, and then we release the males. We also, in every single trial or program that we've done before, we have community engagement. Events like this, to inform people, let them know what's happening, tell them about the technology, and hopefully answer their questions. We then do releases. Those releases can be from pots, they can be from a van, they're just releases. We release every 50 or 100 meters down the road, about 1,000 mosquitoes. Those males then go and mate with the females, pass on the self-limiting gene. Then we have our OV traps in the field to sample the adults to be able to check how well it's going. We analyze the larvae for the fluorescence. I'm sorry you can't see it there. If you can see the screen, you can see the red of the larvae there. And we adjust the release rate depending on that 50% or more or not. And then we just cycle around, keep those releases going until we get that greater than 90% control of the mosquito population. Once we get 90% control of the mosquito population, we can then reduce the number of mosquitoes we release. Because remember, it's dependent on the population, how many release. We can then reduce the numbers and we can keep them at that level. Now, you don't have to keep releasing. You can actually just release in hotspots. The MRCU knows where the mosquito is likely to come back in if you've got rid of it from an area, so you just treat those areas. Or you can stop releases totally and you can just monitor. And if you see it come back, then you do the releases again. So there's lots of options after you've achieved a control to use this technology or other technologies to be able to keep control, keep this mosquito at a low enough level, or even potentially get rid of it from the Cayman Islands, which would be great. So here's some nice pictures of community engagement. Here's some of the Caymanian staff doing their wonderful job in West Bay. And here you can see these white cages. These are full of males. And we get people to put their hands in to show that males do not bite. And it's a very powerful way to show that, because a lot of people don't actually know that, and a lot of people are quite scared of mosquitoes. So it's quite good to show them, look, this is what we're releasing. It does not bite. And then we've been doing some community engagement in West Bay with, I don't know whether you've seen it, but a gazebo. trying to give out information, and that will continue over the next month and into the control program itself. This is the mosquito rearing cabin. Beautiful set of wooden stairs there, leading up to the cabin itself. The cabin is a converted 40-foot shipping container. And inside the cabin, there's nothing mysterious in here. It's just a big wall of trays where we hatch the eggs. We then rear the larvae through to what we call pupae. Pupae are this sort of little, it's a little bit like a butterfly chrysalis. It's where the larvae metamorphose into adults. That's in the water, and then we sort the pupae from the larvae, and then we sex the pupae to get rid of the females. Now we can do that using a mechanical device, because the males are smaller than the females. And we've got this sieve. It's basically a sieve that we can use to sort the males from the females. And then we put the males into a little pot, about a 2-litre pot, allow them to emerge as adults, and then about 2 days later, we release them. And that basically all happens in this cabin here. Up top, we've got, this is a release system in Brazil. It's a truck, and they've sort of using one of the Dyson fans, and they're blowing the mosquitoes out of the side of the truck as they're going down the road. I've said all this before, but releases are made at planned points, and they'll be made at planned points around West Bay, roughly every 50 meters or so. And the males disperse up to about 200 meters in their lifetime. They don't generally go much further than that. They can go about 600, 800 meters, but rarely. So they tend to stay where they are. This mosquito doesn't need to travel far. We provide a lovely home for it. We provide food. We provide a breeding site for their young. It doesn't have to go very far. So where we release this mosquito, it generally stays there. And then, of course, we've got the monitoring. I think I've probably talked this to death until I've got to this slide, but basically, just to reiterate, we have this fluorescent marker as a very powerful tool to be able to let us know how a mosquito control program is progressing, change the number of releases, and also to be able to track this mosquito in the field to show that it is self-limiting and it doesn't spread in the environment. So, in summary, I've almost finished. So, in summary, MRCU and OXITEC are collaborating to fight Aedes aegypti in Grand Cayman. Aedes aegypti is vector of Zika, dengue, chikungunya. West Bay was prioritized due to the high number of mosquitoes, the dengue and chikungunya outbreak, and the fact it makes a very good place to start for a rollout program. In the next phase, the aim will be to eliminate Aedes aegypti from the island again. This is an invasive mosquito. It's not supposed to be here. We want to get rid of this mosquito. The OXITEC-friendly Aedes aegypti mosquito will be released starting in June. Okay, so you all know this will be planned to start in June. Males do not bite. They do not generate any toxin or allergens. We've looked at the protein that's produced, this protein that causes the mosquitoes to die, and it's non-toxic, non-allergenic to humans. This is an environmentally friendly tool. It only targets Aedes aegypti. It will only get rid of that one species from the environment. It's self-limiting, non-persistent. We will integrate it with current control measures, and they will not be reduced or changed. So just to make sure everybody knows, the current tools will still be used. And the WHO has recommended the use of friendly Aedes aegypti, along with the FDA with its preliminary finding of no significant impact. So thank you very much for listening.